Hello, everyone. This is Wang from Hong Kong University of Science and Technology. My topic is orthogonally interweaved data encryption method for screen-to-camera communication. This presentation contains four parts: the introduction, details of the proposed method, the simulation results, and the conclusion. Now let's move on to the first part. Screen-to-camera communication can provide high reliability and high flexibility short-range communication services. SCC systems encode database into images and then display the images on a smartphone or laptop screen. At the receiver side, the user will use a camera to record the images and then decode the data blocks. Unfortunately, due to the broadcast property and the visual nature of display screens, SCC systems are subject to eavesdropping and malicious attack, especially in public venues. Therefore, we propose an orthogonally interweaved data encryption method to enhance the security of SCC systems. Here, I will introduce the details of the proposed orthogonally interweaved data encryption method. Here shows the diagram. At the transmitter side, an orthogonal key matrix is constructed to perform orthogonal interweaving on the data beam stream. Then, the secret key is assembled into database and modulated with color codes. Then, the legitimate receiver's camera will demodulate the color code, extract the secret key, and decrypt the database. Different from the existing method, the proposed data encryption method does not limit the location of the legitimate user to a strict region and can resist attacks from multiple eavesdroppers. Here we modulate the data stream by Cobra color code. The figure illustrates an example of one frame. The secret key sequence is 2031. Then a key matrix is generated by changing the position of the one element in each row. The legitimate user will decode the first four color key blocks and then decrypt the database. However, the eavesdroppers can rarely recover the original database without the knowledge of the key matrix generation rule and the orthogonally interweaving method. Therefore, the security of the SCC system is enhanced. Here, I will illustrate the simulation results. We generate the color code images with different block sizes and add a motion filter to the recorded images. We also develop the information leakage of an eavesdropper to quantitatively evaluate the security performance of the proposed data encryption method. Firstly, we compare the BR performances of the encryption method with different data blocks. The legitimate user with the block size of 30 pixels can achieve the BER lower than 10 to the minus 3 when the motion length is shorter than 5 pixels. By contrast, the BERs of the eavesdroppers are above 0.5, which means they can rarely retrieve the transmitted information. Furthermore, we analyze the security performance of the proposed data encryption method. We can see that the information leakage values of the systems without the proposed encryption method are much higher than these of the encrypted SCC systems. Finally, I will make a conclusion. In this paper, we propose an orthogonally interweaved data encryption method to improve the security of SCC systems. Under this scheme, it is difficult for the eavesdropper to recover the original information without knowledge of the key matrix generation rule and the orthogonally interweaved data encryption method, even if it can retrieve the secret key sequence. Finally, I would like to thank all the sponsors and funding bodies. Thank you all for your attention.